All right. Hi, everybody. Thank you for coming. Happy Thursday before Thanksgiving. Appreciate you being here um, on this chilly and blustery day. Um, Reminders, as you well know, homework 2 is due tomorrow at 11:59 p.m. So turn that in as soon as you have it. That would be appreciated. I'm traveling tomorrow, so there's no office hours. If you do have questions, send me an email as soon as you know that you have one, and then I'll respond as soon as I can. Um, I will post the extra credit homework. I think it may be up already. I just need to adjust um the remainder assignments. So in terms of what's left, it's gonna be the homework 2, extra credit homework if you want it, and lab 9. I think that's it. And then the final exam. So if you finish those, then you're good to go. So yeah, I'll post that by Monday of the break. That way you can work on it if you want. You don't have to work on it. I know what the question is. I just have to go through and make sure that all of the information in there is correct. The question is to come up with something that's worse than BOGO sort. So yeah, so that's the goal. Because BOGO sort is pretty terrible. So it takes some creativity to do something that's worse than that. Um, we're coming up on dead week on the day before final exams. The Friday of the week we come back, that's going to be the last day you can submit things, just because that's the end of the semester. So if you have any outstanding assignments, that's the last possible day. Like after that, I will not accept any late assignments or anything. Question?
How much do you submit some active learnings?
Um, Active learning, no. Labs or homework, yes. Yeah, so the thing is with, so with labs and homework, so active learning is just, it is what it is. You were there that day or you weren't. Labs and homeworks, if you still have things to try and get a better grade or try and understand better, the Friday of the first week of December, last possible day. Because I have to grade stuff and put things into Canvas. That meaning, you should check your grade on Canvas. If your grade on Canvas looks wrong, tell me. If there are zeros in, that means usually that means I didn't receive it. So if you have a 0, maybe do that and then turn it in so that way I can grade it. The Canvas grade should be current with pretty much everything except for lab 8. So if something looks wrong to you, then it's your responsibility to communicate that to me. Otherwise, the grade as it is, plus the things we have left to do, that's what I'm going to put into Gale Express that will go on your transcript. So the grade on Canvas, that's what you're going to get. If there's something that you're confused about or have questions about, you need to tell me. The other thing is that the final exam study guide has been posted on Canvas. It's under the final exam module. So we'll go over it in more detail the Thursday of next time. I can't say next week because that's not true. But the Thursday next time, we will go over the study guide. Most of the questions on the final exam study guide are why. So it requires you to look at the things that we've studied in Java. So like if you take the code that we do in class, look at it and ask, why do we do this? Why is this thing public? Why is it static? What's the return type? Why do we have that return type? And sometimes the answer is really simple. Like maybe for the void return type, maybe you're like, yeah, we don't need to return anything. That's not what this method's trying to do. So yeah, so the final exam, I'm focused on getting you to understand why we do the things that we do. So take a look at that. Let me know if you have any questions. It's your bit of light reading over the break. Okay, any questions or concerns before we get started? Okay, just a reminder. Nope, that's not. Let me pull that up. Open recent. Nope. Where is it? There we go. Okay, so just a reminder for next week, or the next week that we meet. We're gonna do Tuesday, we're gonna look at binary search trees just for fun. That's not on the final exam. And then on Thursday, we'll go over the study guide. I'll have some practice problems. And then you have to be at the final exam Thursday of finals week, 1 to 3 p.m. You must be here. You must bring a writing utensil. Okay. All right, so I'm gonna pause the recording and we'll get into groups. And since last time we didn't finish all the ones, we didn't finish quick sort. So we'll do quick sort. We'll watch as requested. We'll watch the comparison video. And then we'll have some discussion and then you'll work on lab 9 for the rest of the time. Okay, so bubble sort is the one where you start at the beginning and you go through, you find the largest, updating as you go, and then you swap until the largest thing is at the end. And then you go back to the beginning and you do it over again. So you keep swapping until the largest thing is at the end. Knowing like the text of what an algorithm does may be something that you want to remember for the final exam. And in general, just like being able to describe what your code does in words is helpful to you as a programmer. All right, hold on. Okay, so that's bubble sort. Insertion sort is where we've got the part of the array that's sorted already. And we go through it and we find, here's the new, we work right to left, or left to right. And with each new number, we put it in the correct place that's sorted. And we process that way. Something, just a reminder for the final exam, if the array is already sorted, insertion sort is the fastest. Quick sort is also fast, but yeah. If the array is already sorted. Yeah, that's the caveat. Quick sort is superior in pretty much every other situation. Yeah. Selection sort is the one where we go and find the smallest element each time, and then we swap it to the end of the sorted partition. So we're always looking for the next smallest element. Merge sort is the one where we split it in half, split it in half, split it in half. And then as we merge, we put them together in sorted order. And then we've got quicksort. And quicksort is one of the ones that was in like the library video where you choose a pivot is what we call it. So you choose something and then you put everything that's less than that thing to the left, everything that's greater than that thing to the right. And then you repeat the process with the other two halves. So let's watch the video on this one. Okay, so yeah, so go ahead and if you've got your worksheet, that's great. Otherwise, this is the pseudocode. So take a piece of paper, tear it up, first simulate it like with cards. Sorry, I forgot to bring them today. And then write the code based on the pseudocode. Okay, go for it. Okay, so this one we need to be smaller. Okay, so for quicksort, the way this is implemented is we've got a like a wrapper method where we just say quick and then we call the recursive version of quicksort. Because this recursive version of quicksort uses indices to say where are we working. So this is a wrapper method to just do like call it easily, and then we'll call the recursive version that we actually has the parameters that we need. For the recursive version, that's the recursion of calling quicksort on two halves of the array. So initially we say, I want a quicksort from the beginning to the end. And so we call partition that's what chooses the pivot, does the switching around, and it returns here's where the pivot lives. And then we call quicksort on the left-hand side of that. Then we call quicksort on the right-hand side of that. So from low up to the pivot location, and then from pivot location +1 to high. Oh, sorry. Yeah, and so you can see how like in merge sort, the merging is where the sorting got done. In quicksort, the partition is where the sorting gets done, right? Because we're switching everything that's less than the pivot to the left. We're switching everything that's greater than the pivot to the right-hand side. So that's where the actual sorting is getting done. And we're just calling recursively to partition everything in the array. So yeah, so we've got, so the thing with the pivot is like, it can really vary depending on what sort of pivot you chose. It could be really super unbalanced, or it could be right in the middle. So like the video said, there's a number of ways. Median of 3 is one of the ways that you can try and find that out. An easy way is to like choose the first thing or choose the last thing in the array and just go with that. Yeah, and so this is how sorry, it's been a while since I looked at this. So this one has left wall, which is no, actually, I is going through and finding something that's less than the pivot. Wait. I feel like it should be greater than. Yeah, probably. Wait, no. I think for this implementation, yeah, for this implementation, we started the pivot at the very first, like at the beginning of the array. And so as we go through, we find out what's less than the pivot. And so we'll move the pivot to the right. So it's a little bit different from the video, where the video had the pivot stored at the end and then swapped it in when it found where everything is greater than it. This one is reversed. So the thing about quicksort is there's a lot of different ways to implement it, and there's different assumptions in pretty much any implementation.
So if you choose like the first
index in the array, and that's your pivot, then you're working from a frame, but the pivot's gonna be at the front. So like.
Yeah,
the beginning.
so yeah, Quicksort, there's different ways to implement it. And so if you look at 3 different implementations of Quicksort, chances are there's 3 different foundational assumptions. So what I would recommend is, if you're really confused about this, go look up different implementations of Quicksort, pull out your deck of cards and do that, like simulate it based on that code. And that will help you figure out, here's what's actually going on. Okay. Any questions? Okay. All right, so we're running a little bit behind. I have this Quicksort video that I will mute, or not Quicksort video. It's a video of all these different sorting algorithms and shows you what's going on. Let me pause the recording. So I hope that was interesting. So now for the rest of the time, I have some discussion questions for you. So to discuss like kind of what we talked about last time, of which one makes the most sense to you, which is most intuitive, which is not intuitive. Do any of them seem like to you that why would you choose this? And try and think of a reason why you would. Something to think about is, so stability is one of the topics that I ask about on the lab, which to say an algorithm is stable means that we preserve the relative order of things. So when we think of relative order, be alerted to when things like swapping happens. So like if we swap something that could be, like if we've got 2 things in order and somehow we swap them, then that relative order is not preserved. So yeah, so think about, you can also Google like which sorting algorithms are stable. Also think about like which ones have space requirements. So if you can have some sort of answer to these, then you can go and work on the lab. The lab is, it's another one of these like letter ones, which I have a lot of fun with. But it's a library who has rooms of books that they need sorted. And so I've got 5 examples for you to figure out what sorting algorithms could you use, what sort of things apply. So maybe like stable or space that's needed, extra space that's needed. And then which things won't work and why won't they work? And so like a room of novels that need to be sorted by last name, it's completely reversed. Which one do you choose? If you've got a very dark room and you can't see more than 2 books at a time, which algorithm do you use to sort all these books? If you've got a lot of space, which algorithms can you use? It's very small and you can't remove more than 1 book at a time, which ones could you use? So yeah, and so think about that. Think about I'll pull up the questions. The lab is on Canvas, so the rest of the time, a little less than an hour, is just work on the lab and try and come up with answers to these questions, and also think about answers to these questions. So no, yeah, just questions. So open up a Word doc, and if you go along with my silly letter format, you get extra credit. As a group. Yeah, as a group. So I'll create the groups in Canvas. No, so you're working with the groups that you're in right now.
Oh.
Those are the lab groups. And so I'll put those into Canvas. And Your active learning today is just that you're here. Thank you for being here.
So